Hello, all. This is Shobhik from APAC News Network, and we welcome you all in the second edition of the prestigious Sustainable Water Management Conclave series. And this time, we are focusing on building green water infrastructure in Chennai. As we all know that the water is essential to our survival, it is our responsibility to consider water conservation and how we may contribute to posterity and sustainability. With its mission to address the challenges of water management and meet the present day need for building sustainability, efficiency, and resiliency in the water sector, Schneider Electric, in association with the Ministry of Jal Shakti, National Institute of Urban Affairs, and APAC News Network, have partnered to drive greater sustainability in water management. At the same time, to sustain this momentum, Schneider Electric, along with APAC News Network, has initiated the Green Yodha Yatra to create a pan India presence by deciding to directly reach out to water and wastewater related departments and municipal corporations region wise, starting with your region, Chennai this time. With the Green Youth Sustainability Initiative, our objective is to build a community of eco warriors who are committed to adopting and promoting sustainable practices across industries and individuals. So, without taking much time, let me welcome our esteemed speakers for this edition. We have with us Mr. P. Akash, Executive Director of Chennai Metropolitan Water Supply and Sewerage Board. We also have with us Mr. Raj Cherubal, CEO of Chennai Smart City Limited. And we also have with us industry leaders such as Arkul Shenoy, Segment Head, Water and Wastewater Segment, Schneider Electric Greater India Zone, and Mr. Sayaji Shinde, Smart City and IoT Industry Expert from Aveva. Let me first request Mr. P. Akash to share with us his thoughts on the importance of technology and innovation for sustainable water management.
I'll just give you a brief background of CMWSSB and our basic thoughts regarding this, and then I can build on to your question as to what are the technological interventions that will make water management sustainable. Chennai Metropolitan Water Supply and Sewerage Board, we cater to the water needs of the city of Chennai. As you know, Chennai spans, covers an area of 426 square kilometers, and it has almost 8.5 million residents. So, including floating population, you'll have around 10 million people. And in addition to being the water distributor to the people of Chennai city, we also serve as a bulk water supplier to the peripheral areas of Chennai. So, we supply bulk water to the neighboring municipalities and town panchayats, other local bodies abutting Chennai area. So we at CMWSSB believe in three pillars when it comes to sustainability and resilience of water management to the vagaries of climate change. And in each of these three pillars, when I elaborate on them, I will also mention as to how technology plays a major part in that. First and foremost, the source security. So, as you know, Chennai doesn't have any perennial water source, so we are fully dependent on the vagaries of climate. We are dependent on the monsoons. So, we need to make our water sources climate agnostic, and technology plays a great role in it. And one way is, as you know, Chennai has been one of the pioneers cities in India to adopt desalination technology. There are many cons of desalination technology, as in high power costs, high operational maintenance, resulting in higher operational maintenance expenses. And also, there are certain environmental questions being raised, when it comes to the management of the effluent back to the seawater, back to the sea. But ultimately, it's about making the ultimate sources of Chennai's water resources climate agnostic and resilient to the vagaries of climate. So that is one thing. And then we also adopt technology to ensure to frequently monitor the groundwater levels. We do have around 200 to 300 sensors installed in each of the 200 depots throughout Chennai city. So that and if you go to our website, you can see the live state of the underground water table. So that is another way by which we are able to monitor in real time using IoT based devices the groundwater levels of Chennai. The second pillar. I initially at the start of my discussion I mentioned about three pillars. The second pillar is ensuring operational efficiency. So in operational efficiency, we are talking about smart metering, AMR metering, automatic, which gives automatic meter reading. So For pilot, we have just installed around 12,000 meters, and out of that, from around 7 to 8,000 meters, we are getting readings seamlessly and efficiently. So that is one way in which that entails demand side management, so that the incentives of the people as well as the incentives of the utility, that is our utility, are matched. So we can give as much water as per the actual economic demand, and people will restrict their consumption to their actual economic demand. They won't overconsume if there is proper metering. So that is one way. And in addition, we are also talking about renewable energy. Because if you look at our utility power cost, it's around 1,000 crore. Total operational expenses around 1,000 crores a year. Out of those 1,000 crores, our power expenses range from around 250 to 300 crores. That is 25 to 30% of our operating expenses are spent on power. So now we are in the process of adopting newer motors, newer pump sets with VFD, so that the power consumption, and we have done a pilot, and in those particular stations, we have discovered that there is a substantial decrease in the power consumption. In addition, we are trying to go all out on solar. As a pilot, we are putting some 300 kilowatt plant in one of our facilities, and we have permission to do a total of 1 megawatt. So this is a pilot, and going forward, we'll drastically scale it up. So this is the other part where we can drive technology and ensure that our water management is sustainable. And the third part, again, which involves a heavy reliance on technology, is converting this open loop into a closed loop. Currently, what happens is, water is being taken from the sources, it is being treated, it is distributed to the residents. And as you know, 70 to 80% of the water which is being distributed will come out as sewage, as domestic waste, sewage. So these effluents are largely, currently the treatment is around 60 to 70%. And because of the issue in our distribution and collection system, not distribution, sorry, collection system, we are unable to process process and treat all 100% of the sewage. So even the part of the sewage which is like secondary treated as per the emission standards, it's being let into rivers, which is like legal because it meets just effluent discharge standards. But there is a better thing to do. What if we can collect all this sewage back, and after treatment, if it is by some way, after tertiary treatment, if it is like blended with the surface water sources and following a conventional treatment, we can again recirculate it back into the distribution system. So this open loop system will become a closed loop system, resulting in a lot of savings. And to that end, in 2019, we have started 2 TTRO, tertiary treated reverse osmosis plants, treatment reverse osmosis plant, to do tertiary treatment of sewage water with a total installed capacity of 90 MLD, 90 million liters per day. But currently, we are able to sell around 40 MLD. Our capacity is 90, so we are generating and selling around 40 MLD to the industries for industrial use. We have not yet reached a stage in which we can sell the tertiary treated sewage water directly to the public. But I think we are on track for that, because we have in Nesapakam, we are running a pilot plant, which is at an advanced stage of completion, will be complete. A trial commission is in the progress. So we are putting a 10 MLD TTUF, tertiary treatment with ultrafiltration. It's a tertiary treatment facility. It doesn't have a reverse osmosis. It stops at the level of ultrafiltration. And following UF treatment, the tertiary treated sewage will be blended with a Porur lake, one of the lakes. It's a surface water source. It's a smaller lake. So that lake has its normal surface water, and tertiary treated sewage will be blended into it, and the blend will be distributed to the public following a normal conventional treatment of that blended water. So these are like, again, TTUF, TTRO is we are adopting the latest cutting edge technology when it comes to these treatment processes. So this is a broad overview of our current and future plans, and how technology plays a major role in each of these pillars of sustainable water management. When it comes to industrial partnership, I'll say that the primary partnership that is required is a captive, an agreement to consume or treated sewage water. Because initially, when we started up, a lot of industries had a lot of concerns. They had a lot of concerns with respect to the quality of water, with respect to whether the water being treated conforms to their standards. So we had to have a lot of confidence building measures, and we invited the industries to visit our plants, and we convinced, and they took a number of samples, and they got it tested from their own from labs in which they had confidence. And it was very clear that the that the tertiary treated sewage water is purer than even the mineral water that you buy from the market, because the TDS is around 40. TDS of tertiary treated water which we are supplying is around 40, while the TDS of the desalination plant water from the desalination plant which we supply is around 450 to 500, and the TDS of the treated surface water plants from where we take water from the lakes and treat and distribute to the public following a conventional treatment. In those plants, around 250 to 300. But the tertiary treated sewage water, it's much more pure. The TDS around 40 to 70. It's like much purer. And the industries are able to take those water, and because industries need the water at a much higher purity, and this water definitely meets their standards. But the major challenge has been that while commissioning the plants, we calculated the future demand, and we arrived at 90 million liters per day. That's why we put two plants with a capacity of 90 million liters. But as you know, in the last couple of years, Chennai has been getting copious monsoon, copious rains. So the industries, they themselves get a lot of water from their own underground water extraction, or many of the industries have captive water sources within their premises. They have huge premises, 50 acres, 100 acres. So they have huge water tanks and water like lakes within their own premises, which get full when there is copious monsoon, and now they are not dependent on us. But during drought season, when there is general scarcity of water, definitely our full 90 MLD capacity will be utilized. So I think here, some better partnership with industries is required when it comes. Industries should commit to yeah, consume the tertiary treated sewage water as a matter of principle and practice. And I think some legislation can also help. And coming directly to a question of adoption of technology, yes, currently we don't have any. We are not directly commissioning any major plant in PPP mode and deboot or anything, because we had one. Our first desalination plant at Minjur was inaugurated in 2010. In a PPP model, because the industry invested the capital upfront, and now we are paying per million liters of kiloliters of water, and that cost includes the the amortized hybrid annuity model calculation of the initial capital outlay also. But as of now, when it comes to the TTR or the new desalination plant, it is fully on a it is fully owned. It will be fully owned by us, in the sense that we'll be just floating tenders with global participation. So even when it comes to the latest technology, international technology, we are not restricting our competition to any domestic industries. So international companies are bidding for all our treatment facilities and desalination plants and reverse osmosis plants, and they bring in the latest, and our pricing, our estimates are prepared in such a way that it doesn't hamper competition, that it doesn't it gives scope for the adoption of the latest technology as long as it is reasonably economical. So we encourage global competition, and people from international competitors bid, and they bring in the technology. And I'll give you an example. In this, we are having a 400 million liters per day desalination plant, which is in the pipeline. It's in the tendering stage. In that, we have given a base technology, and in addition, and so if and we have four bidders who have qualified in the request for I think RF request for a proposal, the first stage. Um, uh, they have qualified and come to the bidding stage, and these four bidders, in addition to giving a quote on the base technology which we have proposed, they are free to give the quote for an alternative technology which they believe is better at operational efficiency and more conforming to global standards and practices. So what we'll do is, if the bidder submits two technologies, that is one base technology which we propose and an alternative technology, we'll be evaluating both of them with an open-minded with an open mind, and then we'll be selecting what is best for us. So that is it when it comes to industrial adoption, industrial cooperation to enlist new technologies. To conclude this in as short and as meaningful way as possible, there's only one small thing which I need to say, that we should start recognizing the value of water. It is as simple as that. Whether it is utility or the consumer or the industries. Once we actually start realizing the value of water and we start putting a price on it, which fully reflects the economic value of water, not just economic value, economic, environmental, social value of water, and act towards the sustainability, I think we are in good shape. And I fully appreciate the efforts of Ministry of Jal Shakti and Schneider Electric and your organization, which has been the pillar of this movement. And I sincerely hope that the value of water is fully appreciated by the people, and this movement does its role in promoting the value and importance of water, and maybe help in changing the thoughts of utility and governments and other service provider, and make a shift from the current thought that water is something which, yes, definitely it's a basic human right, which needs to be provided, but it is also a valuable resource, valuable economic resource, which should be properly, its value should be recognized. And I hope this movement goes a long way in promoting that. Thank you.
Thanks, Mr. Akash, for sharing with us your thoughts today. We have got great insights from you today on how government and industry can collaborate for effective and sustainable water management. Now we move to Mr. Raj Cherubal, CEO of the Chennai Smart City Limited. Let's hear from him now.
I think from a Chennai's perspective, this is a city which has had droughts many times, and it has had floods, and water is a very, very important issue in Chennai. So obviously, we need to start. I mean, government of Tamil Nadu has already initiated quite a few projects in Chennai, in various departments, agencies, sectors, and so on. But we have a long way to go because as any Chennai will say that our rivers, our water bodies, many of them are in bad shape, many of them have been encroached, many of them have disappeared, and many of them have been built over. Yeah? So ability to handle rains and store the water underground, ability to keep the water clean, etc., has been damaged to some extent. But I think in the last few years, I think Chennai has done quite a few interesting projects, and I can describe to you some of them. But and also now with climate change and a lot of discussion on resilience and so on, there's a lot of emphasis on water, and not simply in terms of drinking water, but also in terms of how do you restore water bodies, how do you ensure recycling is happening, and so on. And one issue is that some of these things are across various departments, various institutions. And when we talk about sustainable water, we need to also think in terms of what are the institutional arrangements in a city, so that you can have better coordination, better integration of the plans, so that right from receiving the rainwater, storing the rainwater, all the way to conservation, encouraging people to conserve, and so on. These are all taken as one part of a big plan, rather than bits and pieces. First of all, before we get to the technology, we need to protect environment and nature with the basic idea of science and technology and engineering, to ensure that all our water bodies are preserved. If they're in bad shape, we need to restore them ecologically in a scientific way, using ecological principles. So we don't put just concrete around the water body and make it into some kind of a park. Rather, look at the biology, zoology, and every scientific aspect of it, and restore, whether it is a small water body or a large water body. And as you very well know, the water bodies are part of a larger system, large tanks, small tanks, temple tanks, and so on, running into small canals and rivers. So we need to look at this entire system as one ecosystem, which means your GIS and mappings and or hydrology mapping, underground water mapping, all these things become very, very important part of any good ecologically conscious city. And the use of data to not only do master planning properly, and also taking resilience, climate change, and other issues into account, so that we are planning all those pieces. So there itself, there's a lot of technology involved. I mean, unbelievable amount of technology and data is involved. And Chennai, as I've said in many other forums, we have the Greater Chennai Corporation ended up restoring about 210 water bodies, which is a huge achievement, and around 60 odd temple tanks. And all these water bodies and temple tanks now attract birds, and people can come and enjoy the place. Also, many of these temple tanks will have wells so that the water is getting into the underground reservoirs. So that is one part of it. Then the other piece will be to say using technology to, as Metro Water and others are doing, and Chennai is supposed to be a pioneer in this, where the attempt should be to recycle every drop of water. So the cheapest thing you can do compared to desalination, etc., from what I understand, is making sure that every drop of water, like Singapore, I think, does, to ensure that each drop of water is recycled and reused, so that the stress on nature is reduced. The third piece would be to use smart technology, smart metering, etc., to measure. And as they say, what you can't measure, you can't manage. If you don't know how much water is being produced, how much water is being supplied, who's using how much water, and so on, you can't manage it well. So Chennai here, as part of Smart City and other projects, a lot of bulk metering and commercial building smart metering has been done. So, for example, one very interesting project is a lot of water is supplied through tankers. And earlier, they didn't know how much, Metro Water didn't know how much these tankers are taking from their water stations. So they have an ATM concept now, funded by Smart City, where the driver gets a ATM card. You put the card in, and the card has a installed number that says this many liters of water should be released, which means Metro Water is able to start measuring how much each tanker is carrying. So these kinds of technologies, etc., are extremely important. And also, as everybody knows, behavioral economics or nudging plays a huge role in conservation of water and other natural resources. So, for example, if people, you and me, don't know how much water we are using, it is not very easy for human beings to. We can talk about conservation, but it's very difficult to be green and be practicing conservation. So I think, like other cities have done, where the consumer knows how much water was used, how much. One good way to change people's behavior is to know how much your neighborhood is using. So from what I understand, no matter what you talk about nature, global warming, etc., some people change, but most people will not be able to change, because that's human nature, right? Uh, but if you tell me that everybody else in my neighborhood is using 100 units of water, but I am actually using 200, immediately my brain starts trying to figure out, why am I using so much water and how I can reduce, right? So all these pieces involve technology, smart metering, etc., etc. And the other thing, last point I would make is that, see, one of the issues that comes up when you do water body restoration, etc., is people sometimes can be cynical or even skeptical and ask, how are we going to monitor these things? And it's a very important, valid question. Now, how are we going to ensure that these water bodies are not getting destroyed? So here also we have explored, and I hope somebody can help us solve these problems. That is, can we use satellite technology? Can we use drones to keep an eye on the water body? Can we do artificial intelligence and image processing to figure out, if is the water body shrinking, is it expanding, is somebody encroaching, is somebody building a house or something next to the water body or inside the water body? These kinds of tools are required for any city, especially massive cities like Chennai with limited resources, to be able to manage our precious water resource. I think Jal Shakti and others have the capacity to scale and reach these messages to a larger audience, public in general, for sure, because after all, if citizens are not part of it, I don't see I don't know how any of these things will succeed. But also, I think the capacity is missing in our city. So whether it is a simple water body restoration to bigger and bigger restoration and other projects, what kind of smart meter to be used, what technology works, what doesn't work. So we need to move from theoretical concepts and YouTube videos to actual implementation of these projects. Here also, I think Schneider and others and Jal Shakti, various state governments can help us build capacity of the city to do bigger and better things. See, other cities probably had 100 years, 200 years to think and slowly get to this point. Our cities in India, we have so much pressure, so little, I mean, limited resource, limited capacity, and the pressures are increasing every day. And now there is a, I mean, if somebody's going to talk about resilience, somebody's talking about climate change, etc., it becomes very difficult for the system to react and do the right thing. So I think campaigns and capacity buildings are going to be extremely important to speed up all these things. How do we get to an advanced cities level within a few years' time, rather than waiting for decades or centuries? So I think it's going to be very important that we build capacity in public and in institutions, in agencies, in corporations and metro waters. How do we build capacity? I think Jal Shakti and others can make a huge difference.
Thanks, Mr. Cherubal, for sharing with us your vision on the importance of technology and capacity building activities to build a sustainable urban water management ecosystem. We heard from the leaders of the government till now. Let's have the perspective from the industry stalwarts as well. We have with us Mr. Arkul Shenoy. Let's hear from him now.
Thank you, Savik. Pleasure to be a part of the event. Sustainable living is the way of life. The Green Yodha movement for water empowers individuals and the stakeholders to embrace efficient, sustainable, and resilient practices in water management with the use of GenNext technology and automation. Here are some of the key challenges that are faced by the water industry in India today. With the world's second largest population, the largest concentration of aspirational population, and improving lifestyle, increasing per capita water consumption, booming industrial growth, and one of the largest farming communities ever in the world, our challenges can be put into 5 key brackets. 1, access to safe and adequate water. Now, the drinking water is being pushed aggressively by ambitious government programs and schemes such as Jal Jeevan Mission, Amrit 2, etc., and is also part of the smart city mission in a lot of cities where this is getting implemented. This is largely in order to satisfy the demand of more aware and demanding citizens who are keen to have water, the right amount of water, the right quality of water, etc., and hence enhancing the quality of life for our common citizens. The second one is the capex constraints, where we are always challenged to provide the right equipment and technology at the right cost, which will be capable of withstanding the demanding requirements. And this is critical for for public projects which are getting implemented. Third, perhaps the most critical to ensure equitable water distribution at the right quality, reduction of NRW, which is a hot topic today, including its leakage and the loss component, proper wastewater management, which is again key to the health of our citizens, augmenting water circularity, considering the kind of water stress that we have and the need to maximize the efficiency of the water that's available, meeting the intended social goals, including for schemes such as Jal Jeevan Mission, etc., enhancing the uptime and service level, improving asset life and driving sustainability, and ensuring seamless coordination between multiple water resources, including recycled water, to meet the growing, ever-growing demand of water requirements. Number 4, workforce dynamics. Again, where there is an immediate need to attract the right kind of talent and not just attract, but also to retain the right kind of talent, to maintain and run these assets, enhance governance, and make the sector lucrative generally as a career option for the youth of today. And of course, number 5, water is considered a social subject. However, there is a need to recover the cost and investment so that while the social objectives are met, there is also a self-sustaining model that is put in place for attaining and maintaining the right service level. And this will also make it attractive for the private sector to participate in these projects, either in PPP model or the HAM model or any other model that the government brings forth. Now, technologies based on IoT, artificial intelligence, big data, predictive management, integrated resource management, etc., are all integral to the smart water technologies. And these technologies will play an all important role in driving end to end water management and reuse. For some time now, we've become familiar with automation, SCADA, and things like that. Now, this helps the water operators to monitor, and the stakeholders, of course, to monitor the operations of a plant or a network, to get alarms of any undesired operations and process deviations or any failures or any kind of breakdowns, etc. But any change enablement strategy would have to prioritize sustainability, decarbonization, reducing environmental footprint, combating water scarcity, and so on and so forth. And the surge of digitization today has the potential to revolutionize all of this and revolutionize the world as we know it. The Indian government has long recognized the importance of focusing on development and efficient regulation of countries' water resources, as a result of which the Ministry of Jal Shakti is establishing a long-term water management system to accommodate the current demand for clean, dependable, and inexpensive water, but also to meet the future requirement of this very scarce or important resource, which is water. Now, sustainable and resilient water management is only possible when we scale up the technology value chain, enter into the zone of optimization, integrated operations management, and contextualized end-to-end visualization and decision-making analytics. The key is to empower decision makers with integrated end-to-end visibility, analytics, and actionable information. This includes bringing together information from assets, from operations, from people, and the resources onto a single platform to ensure that all the data and its interdependencies are well represented, well mapped, for an optimum analysis resulting in robust decision-making insights. Let's take a couple of examples. Jal Jeevan Mission, for example, which aims to provide tap water connection to every rural household in the country. Very ambitious, I must say. Well, there is immense focus on making it happen, and it is backed by matching financial allocations. What would, however, be equally important is to arm the local bodies, to arm the local authorities, district authorities, the state authorities, etc., with the right kind of information, so that they are able to, so that they feel adequate and empowered to take the right kind of decisions and quick decisions. The state and the central governments would also want to monitor the progress of these projects, and also to make sure that in real time, the water is indeed reaching the beneficiaries, thereby meeting the social objectives that these schemes envisage. The water segment is at the cusp of technological revolution. Something that I talked about, JJM, is also true for things such as smart water, things which are urban water supply scheme, management of grey water, water circularity, etc. The kind of technology that we are talking of today is something which the power industry had adopted about 15 years back. If you look at the power sector today, they are probably amongst the most advanced in terms of power demand and supply management, power quality management, power availability, asset management, etc. Thereby giving, it has given an unprecedented boost to the Indian economy and has enhanced the predictability. There is still so much to be done in the adoption of IoT-enabled smart water technology to help our customers manage the scarce freshwater resources better, to ensure equitable water distribution, help maintain water quality, monitor and control wastewater discharge quality, help achieve water circularity, and to prolong asset and infrastructure life, while reducing power consumption, help save an operational cost, and become more customer centric and ultimately optimize the cost of ownership across the asset lifecycle. Sustainability calls for all of us to unite in a collective surge of activities that will inspire the warrior in us to make a difference in people's life and fight to safeguard the planet that we all call home. I'm pleased to join the Green Yodha movement to ensure we introduce new ideas and technology to India's water sector. I'm optimistic that this sustainability water management conclave journey ahead will provide the necessary knowledge about innovation, about digital technologies, and about ways and means to achieve sustainability and efficiency in water sector. To ensure a greener planet, I've become a green warrior. This is time to empower all of us to make the most of our energy and resources by acting for a climate positive world, bring efficiency with resources, living up to our principles of trust, creating equal opportunity, harnessing the power of all generations, and empowering our local community. Join the good fight, be a green Yodha. Thank you.
Thanks, Arkul, for great insights on Schneider Electric and how it is transforming water and wastewater management scenario in India by leveraging technology and innovation. Now, let's have a perspective from Sayaji Shinde from Aveva. Over to you, Mr. Shinde.
Thank you, Shavik. Managing water resources is becoming a matter of grave concern for authorities due to challenges created by rapid urbanization, globalization, and climate changes. Water authorities aspire to provide adequate quality and quantity of water. However, they need to deal with issues like aging water infrastructure, which needs substantial capital investment, and the need to modernize water operations to achieve higher operational efficiencies. To address these issues, many countries are investing in building new water infrastructure, like replacing old water distribution networks with new, rainwater harvesting, and taking steps towards modernization of water operation. When it comes to modernization, usage of digital technology has been a prime focus all along. Use of digital technology is not new aspect in the water industry. As technology capability has been growing, the water industry has been adapting new technologies to achieve better operational efficiencies. However, usage of technology is still limited to traditional automations like implementing supervisory and control acquisitions to adopt water processes or to automate the water processes like reservoir operation, water treatment operation, water distribution operation. However, the usage of technology is still limited to traditional automation like implementing supervisory and control data acquisition to automate the water processes like reservoir operation, water treatment operation, water distribution operation. Similar approaches are taken to increase the operational efficiencies of sewage treatment processes and drainage operations. Apart from this, many water authorities have also invested in automated operations which use advanced digital sensors and electrically actuated assets like valves and motor to reduce dependency on workforce. Over the last decade, water authorities also come to understand that traditional digital technology implementation for various processes across water life cycle is essential, but it does not ensure water sustainability, higher water operational efficiency, and resilience required in today's turbulent world. Schneider Electric and Aveva has been collaborating with water authorities across the globe to understand the challenges and aspirations of water industry. This close collaboration has allowed us to have a deeper understanding of water industry. We understood the gap in present digital approach, and we reached the conclusion that water sustainability goals can be achieved if we can track, monitor, and optimize the entire water life cycle from rain to rain. To achieve this ambitious goal, our approach is to make use of a platform technology, which can be implemented in phase-wise manner that leverages our clients' existing investments in digital systems and solutions. We have supported many water authorities across the globe in laying down the foundation of digital transformation in light of rain-to-drain tracking and monitoring of the city or state's water system. One such example I would like to talk about is a province in Malaysia. This province has a total area of 1050 square meter with a population of around 1.8 million people. They have implemented advanced control and sensory system across 9 water treatment plants, 4 dams, 59 treated water reservoirs, almost 41 treated water storage tanks, 90 pumping stations, and sensors to track 4,500 kilometer water distribution pipeline to achieve their water sustainability and energy efficiency goal. However, despite initiating this digital modernization drive, they realize that they can't reach their goal in totality with traditional digital strategy. They feel that they further need to enhance their operations by means of an advanced digital technology to achieve various goals. For example, end-to-end visibility of entire water life cycle and central control operations, ability to track and respond quickly to water supply disruptions, ability to maintain operations based on real-time demand and supply analysis. We collaborated with the provincial government and implemented a central command and control system which facilitate the integration of entire water system on a single state-of-the-art technology platform. The platform has capability of data collaboration, central monitoring and control along with advanced analytics. The outcome of this approach has been encouraging as the Water Authority has achieved first end-to-end real-time visibility of entire water life cycle to real-time dashboards, GIS mapping of all water assets and system, and monitoring and responding to 150 KPIs and incidences from central location, thereby ensuring faster and intelligent response. Second, it allows the real-time digital collaboration of information across water supply chains, resulting in ability to optimize operations like reservoirs, treatment, and distribution based on real-time demand and supply analysis. Apart from this benefit, the transformation has also facilitated the implementation of next generation technologies like artificial intelligence to drive prediction and prescription, thereby further enhancing the operational efficiency. It has also led to efficient and faster water policy making and governance models based on real time and authentic information. The province has realized their dreams of becoming the country's most sustainable water system, which now does not require any water rationing for next 10 years. It is the only province in the Malaysia that has managed to maintain the lowest domestic tariff rate, resulting in a consistent profitable water operations. In conclusion, I would like to applaud the Ministry of Jal Shakti for having a futuristic vision for the modernization of India's water system and the very innovative approach of creating an initiative like Green Yoda Yatra. This approach creates an awareness as to various possibilities through which digital transformation can support the water industry, and we would like to extend our commitment to this initiative and the mission to achieve water sustainability pan India. Join the good fight, become a green Yodha. Thank you.
Thanks, Mr. Shinde, for sharing with us your thoughts on the importance of IoT for sustainable water management and managing water for the smart city infrastructure. And with this, we have come to the end of the second edition of Sustainable Water Management Conclave series. And this time, we are focusing on building green water infrastructure in Chennai. I personally thank all the esteemed speakers who have been part of this event and all the esteemed delegates who have joined us today to watch this. And I'm sure that the deliberations made here today by the governance and industry leaders will have an impact to create the future roadmap for building an efficient and resilient sustainable water management infrastructure. And Green Oath campaign will surely play an important role in creating awareness and to create eco-friendly water warriors throughout the country. I request all of you to join the good fight and become a Green Yodha. Goodbye. Take care.